Hello, welcome back to OConnor Racing. What we're going to do today is we're going to install a sleeve in a cylinder. This just happens to be a blaster again. But these things, you can still find them, but they are getting kind of rare. And when you do find them, it's hard to find something that's standard bore. This is actually going to Canada. He doesn't have a cylinder, so we had this one here. It's not ported, it's not mucked up or anything. It's at 68 millimeters right now. So what we did is we contacted LA Sleeve and got their part number, 5035, and this is just a replacement liner. We're going to bore this out and then do a counterbore on the top for the flange, drop the sleeve in, bore it for the piston, match the sleeve to the cylinder bore, chamfer all of the ports, and then ship this puppy to Canada. And we'll show you how we do this. LA Sleeve does a really good job with these sleeves. By looking at it, you're going to see that the ports are definitely smaller. They should be, because we want to match it to the cylinder. We went ahead and we made a port map of this cylinder so we can make this sleeve go back to all of the original dimensions of the cylinder when we're done. The first thing you do is prep this sleeve, and right here, this is all CNC, and like I say, they do a really good job with this, but one thing I like to do is knock all of the burrs off of it. I just do it with a piece of wet dry 220. Just going to turn it around a little bit. Try not to take anything off the dimensions, the outside dimensions. And just feel it. That does a pretty good job. And that's all set. This is the machine we're going to perform this process on. This is a quick-way boring bar. It's got a built-in stand, clamps on the bottom. And what we're going to do is use these micrometers, measure the outside diameter of the sleeve. We're going to measure the inside diameter of the cylinder. We're going to bore the cylinder to accept this sleeve with a 4/1000 interference fit. So I'm going to stay off about 6. I don't know how anybody else does it, but what I like to do is stay at 6, get my sleeve, take the cylinder, bring it to the honing machine, and then I'll hone the last 2/1000 off. And it definitely leaves a better finish than the bit. Not that it's rough, but what I believe is that by honing it, you get a lot better heat transfer from the sleeve to the cylinder itself. So we're going to get the cylinder measured and the sleeve measured, get it set up, and go ahead and do it. I'm using my 2 to 3 micrometer, and I want to measure this in several spots. I'm getting 2 inches 751 thousandths, but I just want to make sure. You should always check any parts that you're working with anyway. I want to make sure that this thing is round, not distorted, not ovalized. And that's good. So I'm satisfied with that dimension of 2 inches 750 thousandths as an outside diameter, and I'll record that. Next thing I'm going to do is measure the cylinder. The way we're going to record the inside diameter of the cylinder is I'm going to use a snap gauge. These are extremely accurate, much more accurate than a set of dial calipers. So we just drop this in here, open it up, get it on center, and we'll take a measurement with a 2 to 3 micrometer and compare the sizes. We went ahead and put the snap gauge in the cylinder, measured the snap gauge with the same mic that we measured the sleeve with, and I snap gauged it twice. I always do that. I came up with 2 inches 665 thousandths for a dimension on the inside diameter of the cylinder. And I put that against my 2 inches 750 thousandths outside diameter of the sleeve, subtracted it. I came to a difference of 85 thousandths. Now remember, I want this hole to be 6 thousandths smaller than this, so I subtracted 6 thousandths, and my figure is 79 thousandths has to be removed from the inside of this cylinder before we can attempt putting this sleeve in. I'll show you how we're going to do that. We have our cylinder mounted in the fixture for the quick way. The first step is to get it centered. You have to prep the cylinder. You have to have flat surfaces. If you notice something, the cylinder is in here upside down, and that's why I want it. The reason I want it like that, I want the bore to be square to the bottom of the cylinder. I don't care about the top. I can fix the top later. If you bore it the other way, and the top of your cylinder is not perfectly parallel to the bottom, your piston is going to move up and down inside the cylinder at an angle, and we definitely don't want that. This machine's equipped with these little cat's paws. There's 3 3 points, and what we did is we dropped the bar all the way down to the top of the cylinder, way down here. You have uneven wear in a cylinder, so by taking the by adjusting it from the top of the cylinder, that's going to get it centered correctly. You just drop it in and then move the adjuster at the top. That'll push these cat's paws out and align the cylinder. The next step is to go ahead and clamp it down. We're going to cut it next, and here's the cutter we're going to be using. The way that you set the dimension for the bit, this bit just slides around in here. It's just clamped in. And you can set this any way you want. The way you set it is with this micrometer. Special mic just for this machine. But I'd highly recommend, if you have one of these, always blow this hole out. Now I've got this mic set for a 2/1000th cut, and the reason I'm taking so little at first is that's going to confirm if I'm centered on this cylinder or not. If it doesn't hit all the way around, something's probably wrong, or I've got some pretty strange cylinder wear. So I'm going to confirm that next. We're ready to take our first cut and confirm that we are centered. Basically just going to turn the machine on, throw the feed lever, and what's happening here is the bar itself is actually moving down into the cylinder. That's a good sound. That cutting tool is hitting all the way around the cylinder, completely perpendicular to the bottom. And we'll just let that run right through the whole cylinder, watching it carefully, seeing what we have. One thing you have to be careful of if you're using this type of equipment is the parallels have to be flat. We have ground parallels on the bottom, we have ground parallels on the top. And the other thing is you got to make sure that the bar is never going to come in contact with your shims or your parallels. These really don't take long to go through the hole, but it does take a little bit of time. And one thing that's nice about this machine is this stop feature that it's got right over here. I can set this so when it comes down, it hits this trigger, and that'll shut the machine off. So what I'm going to do is I'm going to go multitask. I'm going to go do something else while this is doing its job. Again, like everything that we film in here, some stuff is kind of hard to see, but we just sent that cutter through, taking a 2/1000th cut, and you can see on the cylinder wall, we made contact all the way around. So I'm going to say that we're as close to being on center as we need to be, and I'm going to start dialing cuts off of 10/1000ths and blow the rest of this open. We finished boring the inside of the cylinder to accept the sleeve, and there's still some cast iron there, but not a lot of it, and that's going to stay in there. You can get oversized sleeves. If you break a skirt off, this sleeve would definitely not be the right choice. If you break skirts off on these cylinders, they have what's called an oversized sleeve. I bore this much bigger, and it's just got new skirts on it, but for what we're doing here, this is going to be fine. We measured our sleeve at 2 inches 750 thousandths, and as I mentioned, I wanted to get this out of the machine and have this hole 6 thousandths smaller. I'm going to hone the last 2 thousandths for good heat transfer, and it's going to be a 4 thousandths interference fit. So now I've taken my bore gauge and set this up 0. You probably can't see it again, it's right here, but as I check this, the needle keeps going, and it went exactly 6 thousandths, so I achieved my dimension here. The next thing we're going to do, we're over here in the Bridgeport, and we're going to use a boring head. I'm going to center this with the center of the spindle on the Bridgeport, and I'm going to cut the counterbore in for the flange on the sleeve.